Welcome to this video. This video we will look at how we can create a standard cluster in Google Kubernetes Engine. Also, we will look at how we can deploy a sample .NET Core Web API. Additionally, we will connect the cluster from Cloud Shell. Before we are going to start, we need a Google Cloud subscription and basic understanding of cloud and GCP. First, we will look at basic terminologies in Kubernetes. Then, we will create a standard cluster. After that, we will deploy a sample web API image from DockerHub. Next, we will try to access cluster from Cloud Shell. After that, we will delete the deployment. Google Kubernetes Engine (GKE). GKE is a managed container orchestration service provided by GCP. It allows users to deploy, manage, and scale containerized applications using Kubernetes. GKE simplifies the process of running Kubernetes cluster. It automates cluster creation, scaling, and maintenance. It helps developers and DevOps team to focus on deploying and managing the applications rather than managing the underlying infrastructure. Key features of GKE: scalability and high availability, containerization, Kubernetes compatibility, automated cluster management, integration with the Google Cloud Platform, multi-region and multi-zone deployments. Before we are going to start, we need to understand basic terminologies in Kubernetes. Cluster. A cluster is a group of machines called nodes that collectively run your containerized application. In GKE, a cluster represents a managed Kubernetes cluster. It consists of one or more master nodes that control the cluster states and multiple worker nodes where your application runs. Node. A node is a physical or virtual machine within a cluster that runs your applications. It acts as a worker machine and can be either a virtual machine or a physical server. Nodes are responsible for running pods and other Kubernetes components. Pod. A pod is the simplest deployable unit in Kubernetes. It is a logical group of one or more containers that are scheduled together on the same node and share the same network namespace. Containers within a pod can communicate with each other using localhost. Pods are easily created, destroyed, and replicated as needed. Service. A service is an abstract way to expose an application running in a set of pods as a network service. It provides a stable network endpoint that other applications can use to access the pods. Services in Kubernetes enable load balancing and automatic scaling of pods. There are different types of services such as cluster IP, node port, and load balancer. Load balancer. A load balancer is a networking component that distributes incoming network traffic across multiple nodes or ports to ensure optimal resource utilization and high availability. In GKE, a load balancer service type automatically provisions a cloud load balancer to distribute traffic to the ports within the cluster. It provides external access to the service and distributes traffic across multiple nodes or ports based on a set of rules. We will create a standard cluster using GCP Web Console. Go to GCP console. First, we will create a new project. Enter a project name. Create. Project has been created. Next we will create cluster. Search for Kubernetes. Click on Kubernetes cluster. We need to enable Kubernetes Engine API. Click on Enable. It will take few seconds. API has been enabled. In the left side, you can see different menus like cluster, workloads, service and ingress, applications. To access those menus, first we need to create a cluster. Click on Create. By default, it will go to Autopilot cluster creation page. First, we will check with the standard cluster. So we will switch to standard cluster. Click on Switch to standard cluster button. It will ask for confirmation. Click on Switch to standard cluster. First, we need to provide cluster name. In the right side, you can see the estimated monthly cost. Next, we need to select location type. Two options are available. One is zonal, another one is regional. Inside the zone dropdown, you can see different zones. We are going to select regional. In regional dropdown, you can see different regions. We are going to select US Central one. Next, we need to specify default node location. By default, Kubernetes Engine runs nodes of a regional cluster across the three zones with a region. If you want to select manually, we can specify here. We are going to select US Central 1A, 1B and 1C. In the right side, you can see the estimated cost. Now it's 383. Next, we need to configure control panel version. Two options are available. One is static version and another one is release channel. We are going to select release channel. Under release channel, you can see rapid channel, regular channel and stable channel. We are going to select default one, regular channel. Version also, we are going to select default one. Next, we will configure node pool. A node pool is a template for group of nodes created in this cluster. The new cluster will be created with at least one node pool. We need to specify a name for node pool. By default, it will be default pool. Next, we need to configure nodes. By default, it will be 3 nodes per zone. We selected 3 zones, so it will create 9 nodes. If we reduce the number of nodes, it will reduce the total cost as well. Right now it's 383. We are going to change 1. Now it will create 1 node per zone and current cost is reduced to 176. Next we need to configure node settings. Image type, we are going to use default one. You can see other options as well. Next we need to configure machine. We are going to use E2 series. By default, machine type will be 2 CPU and 4 GB memory. We will change to E2 small series. It will reduce the cost as well. Next we will configure boot disk type. We have 3 options are available: standard, SSD and balanced. We are going to use balanced persistent disk. Also, we need to specify the size. By default, it will be 100 GB. We are going to change 15 GB. It will also reduce the total cost. Disk encryption, we will leave it as it is. We will enable Spot VM. Spot VMs are compute engine instances that provide no availability guarantees but are priced lower. So it also reduces the total cost. In our case, spot VMs are fine. Now current estimated cost is $88.51. We have other tabs as well like networking, security, metadata. We are not going to change anything. We are keep it as it is. Under the cluster, you can see networking tab. By default, it will be public cluster. If you want to access from outside, it should be public cluster. Other settings, we will keep it as it is. Cluster configuration is completed. Now we are going to create the cluster. Create. It will take few minutes to complete. Cluster has been created with 3 nodes. We will check the cluster details. Click on Sparrow cluster. Region US Central 1. A zone we are selected US Central 1A, B and C. Release channel, regular channel and version. Number of nodes 3. You can see the endpoints, both external and internal. Under the nodes tab, you can see the node pool. Also, you can see the nodes. 3 nodes are created. We will check the virtual machine instance. Go to the compute engine, VM instance. You can see the same 3 nodes here as well. This same node is showing inside the cluster as well. Deploy a sample image from DockerHub. Click on deploy. First we need to configure container. Here we can create new container image or you can use existing container image. In new container image, we need to select repository provider, then repository, Docker file and image name. We are going to use existing container image. Here we can enter an image path or we can select image from container registry or artifact registry. Right now we don't have any images available in both the artifact registry and container registry. So we are going to enter a public image from DockerHub container registry. I have already pushed an image to DockerHub container registry. We are going to use this image. I suggest you to watch this video, Container Registry and Azure DevOps. This video I am explaining how we can build and push images into different types of container registries like DockerHub, Azure Container Registry, Elastic Container Registry and Artifact Registry. I will provide the link below description. Select Core Web API, copy the image name, paste the image name. Next we need to provide the tag. We will use v1 tag. Next we need to add environment variable, add variable, enter the key, value, then continue. In configuration section, we need to provide deployment name and namespace. Configuration YAML. Kubernetes deployments are defined declaratively using YAML file. We can see the YAML file. Click on View YAML. You can see the deployment, image name, environment variable, everything. Continue. Expose. This operation creates a Kubernetes service. It will receive the traffic and define how your deployment is exposed. We need to specify port and protocol. Also, we need to provide service type. We are going to use load balancer. It will create an external IP and we can access through internet. We have other two options as well, cluster IP and node port. We are going to use load balancer. Click on deploy. It will take few seconds to complete. Now deployment is completed. You can see the cluster, namespace, label and replicas. You can see the services. One service is created with the external IP. Also you can see the one revision is created, events, logs and YAML files. Next we will try to run the application. Under the Ingress tab you can see the services. External load balancer is created an external IP. Click on external IP. Application is up and running. We will try to execute the API. Execute. It's returning values. Access cluster from Cloud Shell. In this session, we will look at how we can connect cluster from Cloud Shell. In the top right corner, you can see a Cloud Shell icon. Click on that. It will take few seconds to initialize. Open new window. We will use gcloud utility for connecting cluster from Cloud Shell. We need to get the credential. Gcloud container cluster get credential, cluster name, region name and project ID. Copy. Go to Cloud Shell. Paste. It will ask for authorization. Authorize. Now cluster is connected with gcloud. You can see kubeconfig entry generated for Sparrow cluster. Using the ls command, we can list the files and directories. Next, we will check the present working directory. We will try to open the kubeconfig file. List the files and folders. Cat kube/config. You can see authentication token, cluster name, everything. What is kubectl? Kubectl is a command line tool used to interact with the Kubernetes cluster. It is the primary command line interface for managing and deploying application on the Kubernetes. kubectl allows you to perform various operations such as creating and managing pods, service, deployments, replica set, namesets. Deploying applications. You can use kubectl to create and manage resources like pods, deployment, services, and ingress controls to deploy your application on Kubernetes cluster. Managing resources. kubectl provides command to list, create, update, and delete Kubernetes resource. You can use it to inspect the state of your cluster, view resource details, scale deployment, and manage configurations. Interacting with the pods. You can use kubectl to view logs from pods, execute command, or run interactive shell session within the container, and retrieve information about pod status, IP address, and resource utilizations. Debugging and troubleshooting. kubectl offers various features for debugging and troubleshooting, such as viewing events, describing resource, accessing container logs, and executing debugging command within pods. Applying configuration files. kubectl allows you to apply YAML or JSON configuration files to create or modify resources in your cluster. You can use this method to define and manage your application desired state. Managing cluster resources. With kubectl, you can manage cluster-level resources such as namespace, persistent volume, secrets, config maps, and more. First, we will check the kubectl version. Kubectl version You can see both the client version and server version. Client version is 27 and server version is 25. You can see one warning below. Version difference between client and server exceeds the support minor version skew of plus or minus 1. For time being, we can ignore this. First, we will list the nodes. kubectl get nodes. You can see 3 nodes are listed below. We configured one node per zone. That's why it's created 3 nodes. Next, we will list the pods. kubectl get pods. You can use short form as well. kubectl get po. The kubectl describe command in Kubernetes is used to provide detailed information about various Kubernetes resources. First, we will check pod information. kubectl describe pod name. You can see the name, namespace, node name, start time, image name, everything. We will check the node name inside the cluster. Also, you can see the internal IP address, container informations. You can see the environment variable, ASP.NET Core environment. Last, you can see events. First, it's scheduled, then it's pulling. After that, it's pulled, container created, container started. Next, we will list the services. kubectl get service. You can see the new services, API core service and load balancer IP 34.27.100.198. This same IP we are used when accessing the application. You can also use SVC, kubectl get SVC. The same result will list. Next, we will describe service. kubectl describe service name. You can see the service information. Also, you can see the external IP. Bottom, you can see the events as well. Delete deployment. This session, we will look at how we can delete service and pods. Under service and ingress, select service, delete. It will take few seconds to delete. Now it's deleted. We will check in Cloud Shell as well. kubectl get service. You can see that service is deleted. Next, we will delete pods. Under the workloads, you can see the pods. Select, delete. Now pods are deleted. We will check Cloud Shell as well. kubectl get pods deleted. No resource found in default namespace. First, we created a standard cluster. Then we deployed a sample web API from DockerHub. After that, we connected cluster from Cloud Shell. Finally, we deleted the deployments. I hope everyone understood this session. If you have any question, please put them in the comment section below. Thanks for watching.